Understanding circuits, current flow, and series circuits will help us better understand how our X-ray machines take X-rays. There are two different types of currents that we're going to talk about, one being direct current and the other being alternating current. With the direct current, the electrons flow in one direction around the conductor. Some common examples of direct current would be a battery, a flashlight, your cell phone, remote control, and the X-ray tube itself is a direct current. With an alternating current, the electrons will begin flowing in one direction and then will turn around and then go back the original and then go backwards, and it just alternates this pattern back and forth. Some examples of this would be really anything that you would plug into a wall socket, be it a coffee maker, microwave, a hair dryer, anything of that sort. With an alternating current, the electrons will flow in a positive direction and then flow in a negative direction. These type of currents require a generator to produce. Like everything else in science, we're able to measure how often the current fluctuates from positive to negative. The unit of measurement we use is the Hertz, which is the frequency of cycles per second. To understand what a cycle is, look at this picture. Notice that the blue line starts off at 0, it goes up to V positive, back down to 0, then to V negative, and finally back up to 0. That right there is one cycle. Hertz is the measure of those cycles per second. So for example, if we say something is 60 Hertz, that means there are 60 complete cycles per second. If you're looking at a circuit diagram, there's an easy way to tell if it's running on DC power or AC power. On the left, you'll see a symbol for DC power, which are those parallel lines. And on the right, you'll see the symbol for AC power, which is that sigmoid. This is a basic example of what a series circuit looks like. In a series circuit, all of the components are connected in a series along a single path. And so, what are these components? First, you see the parallel lines on the left, which represent that this circuit is running on DC power. Next, these flat lines represent conductors, and the jagged lines represent resistors. You might see a couple additional symbols around the circuit. The top symbol you're already familiar with, that's the resistor. The next one below that are parallel lines, which represent a battery or DC power. And then below that is a capacitor, which temporarily stores electric charge. Below that is a transformer. Be very familiar with this symbol because it's going to be important to us later. Another important symbol below that is the diode that forces electrons to go in one direction. Again, that diode is going to be really important to us. In a series circuit, the total voltage is the sum of all the voltage. And just like voltage, the total resistance is the sum of all the resistance. However, with a series circuit, the total current is equal throughout. As you watch the circle go around the circuit, think of the circle as our measuring device, and it's able to measure current at any point on this series. Notice that it remains 2 amps throughout the entire circuit. So let's find the total voltage on this series circuit. We know that total voltage, or VT, is the sum of all voltage on this series. We can see that we have one battery or DC source on the left at 4 volts and another on the right of 6 volts. So we just need to add those together, and our total voltage for this series circuit is 10 volts. All right, now let's try resistance. Here we have 3 different resistance. We have 2 ohms, 3 ohms, and 5 ohms. So if we add all of that together, our total resistance is 10 ohms. Putting all of the equations together looks something like this. I would highly suggest you practice drawing this series circuit and writing all of its equations inside it. Let's do a practice problem and try to solve for current, or for amps. First thing we need to do is find the total voltage. In this case, it's 20. Then we'll find the total resistance, which is 10. Next, let's plug those numbers in our Ohm's law triangle. And then to solve for I, we just take 20 divided by 10, which is 2. So in this series circuit, there's a total current of 2 amps. Now let's try something a little bit more challenging. This time we're going to solve for total resistance. But as you can see, we're only given two values, total volts and total watts. So how do we proceed? Well, the first thing we want to do is include both the Ohm's law triangle and the watts triangle. Then let's start filling in our values. So for the volts, we can put in 200, and for the watts, we can put in 1000. Now that we've inputted the values, is there anything that we can solve for? Well, yes, we can solve for current based on that bottom triangle. So we'll take 1000 divided by 200 to get our total current. And our total current in this case will be 5. Next, we can move that total current from the bottom triangle up to the top triangle. And now we can solve for total resistance using the Ohm's law triangle on top. What's 200 divided by 5? It's 40. So the total resistance for this series circuit is 40 ohms.